All right. Good morning, everybody. I'm Trey. I'm team lead, and I work with data acquisition. We have Jamel, who was also our lead for data acquisition, as well as one of our software developers. We have Dan, who is our lead software developer. We have Marilyn, who is our lead hardware developer and implementation, as well as Emmanuel, who is in charge of hardware development as well. So our project is IoT-based, so a little bit of background regarding it. Current IoT-based capabilities take in user input, pass it up to the cloud where a lot of the input is processed, and a corresponding course of action is sent back to the IoT device in order to implement a specified command. With this current implementation, there's a lot of different privacy concerns. It's doing a lot of this within the cloud. There's different latency and network congestion issues just because there's many users trying to access shared resources. What we've done is utilize neural network machine learning on the actual IoT edge node hardware itself, so to really cut out the middleman and really be able to do a lot of this command recognition on the hardware devices itself. And then that way we just free up a lot of the space within our cloud implementation to be used for different means.
Our goal was to apply the classification capabilities of machine learning and apply it to a low-powered microcontroller. In order to train our network, we had to procure an IRB from our university in order to gather data samples from over 55 individuals. From there, we took our data samples and trained a deep neural network that was about 4 layers, and then we were able to compile it onto an MSP430.
From there, the overall results we acquired were we were able to implement our deep neural network on a TI-based microcontroller MSP432 with a 200 kilobytes of flash memory. And we were also able to train our network with these different data inputs with an accuracy of 95%, as specified by our corporate sponsors, Texas Instruments.
Future implementations of our device will be able to promise to limit bandwidth by providing traditional cloud classification locally. Picture miniature Amazon Alexas in the walls of homes and offices around the nation, able to listen in for keywords and being able to turn off lights, fans, adjust temperatures. Connection to the internet will be used to perform analytics, update the network, and change functionality of our microcontrollers. Thank you. Is there any questions?
Yeah, what was the parameter you were measuring, and what remediation process did the IoT device do to correct that?
Yeah, to attach to that, because I was going to ask about the same thing. So your original goal is, I think at least from the abstract, says reducing latency, right? So
that's correct.
How much you improved, attached to this?
What was it? What did he say? What was the?
He was asking about how much the team addressed latency. That was one of the issues on the IoT.
Oh, okay, because I just want to know what they were measuring and what the remediation process was to fix it.
So to answer your question, what we were measuring is the accuracy of the keywords that were spotted, and that's what you're seeing with the 95%. And as far as latency, I'm not exactly sure if we have a figure for addressing
regarding latency, since a lot of our actual processing is done on the actual hardware edge node itself, as opposed to going out to the cloud, it significantly reduced the amount of latency, because in a typical standard, there's many resources trying to utilize a similar cloud-based environment. But in our implementation, we pretty much just cut that out with regard to this. So when it comes to specified figures, I don't have a value, but just in general, we significantly reduced latency just because there was no need for it to do the processing within the cloud-based environment.
Okay, I just want to say that abstract says that you're actually trying to solve latency issues within these devices.
Yes, sir.
How many commands did you accept? How many different commands?
We've collected about 6 commands.
6 commands? Okay.
Yes.
All right.
Which IoT technology did you use?
I'm sorry?
Which IoT technology did you use? Like LoRaN?
So for this implementation, there was no connection to the internet. We were just simply applying machine learning to MSP432 in this situation. And so for future deployments, however, there would absolutely be connection.
So, okay.
So when you
Last
got,
question.
okay. When you got the local command, what did you do? What did that machine do when it saw the local command? Did it light up a light? What did it do?
Yes, sir.
It lit up a LED light system, powered a fan, general just proof of concept outputs.
Okay.
Quick question.
Where is the neural net running? for the recognition? Is it running in the cloud or is it running?
The neural network is running on the MSP 432 itself.
Okay. How many total nodes approximately do you have on that?
How many total nodes?
Uh-huh.
So are you asking how large our network is? or-
You know, each layer is nodes, right?
Yes, absolutely.
Okay. So totally, you had 4 layers?
It's 4 layers, 144 each, and then
Okay,
it singles
4
down
times
to about
that.
8
Okay.
at the last
Uh,
node, or layer.
And what is the size of your vocabulary, the commands?
That was about what, 6,
The
8?
input.
It is 8 words.
8?
Yeah.
Okay, and you were using the word keyword spotting. Was it keyword spotting or
Yes,
just
sir.
spoken isolation? Or can I
Keyword
say
spotting.
something and just turn on this machine, Jack, or something? I say other things too. Do you do that?
No, sir. Currently, our current implementation is simply keyword spotting, so you have to know the set command list.
I don't know what you mean by keyword spotting.
Keyword spot-
spotting is a different word. Command input
There,
is a
there's,
different.
there are specified commands that the network
Okay.
listens in
Those
for.
are spoken in isolation, not embedded in a sentence.
Yes.
Yes.
So
If it's embedded in a sentence, it's keyword spotting, not otherwise.
Okay, sorry.
Okay.
You're doing closed word recognition, not keyword
Yeah.
spotting.
Okay.
All right,
You
let's
do.
thank this team.